We're now going to look at river capture. We've discussed river capture before, but let us look at river capture now and how it is seen on a topographic map. Here's the topographic map, and notice what the topographic map shows us. That on the eastern side of the map, we have a steep slope. On the western side, we have a gentle slope. So therefore, it means that the rivers flowing on the eastern side are flowing much faster and so have greater erosive potential than the rivers on the western side. And it's for this reason then that headward erosion has occurred there as indicated, and you can see how it is cut back because the line that runs diagonally across the slide shows where the position of the escarpment is. And you can see at that point that is highlighted, that escarpment has been cut back. Let us now look at this area in greater detail. There we see the area that we're talking about, and we can clearly see when we examine it that the watershed has been cut back. And we can clearly see an area where headward erosion is taking place. You can see how that river, the Mzimkhulu River, its headwaters are cutting through the Drakensberg and cutting right into Lesotho itself. And so there we see headward erosion, and because we have headward erosion occurring in this area, river capture would take place, because as the river cuts back, it will capture the headwaters of the river flowing on the other side of the watershed. Let's look carefully at this area of capture, and now we can identify the different features in the area of capture. First of all, we have that area there which is the elbow of capture. Notice how we see the elbow. It's got a bend in it, so therefore the river used to flow in a different direction before, and now that area now has caused the river to change its direction. And so where we see that clear elbow, we call that an elbow of capture. When we look at that stream and the stream to the north of it, you see that that stream doesn't fit into its valley because its headwaters have been taken away. And so that is why that river is called a misfit stream. And the area where the river used to flow and now is dry, that's called the dry valley. And then notice how the river that does the capturing, the capture stream, has cut a very deep channel. And it's able to cut that deep channel because it has greater erosive potential. And so that is why then it's able to cut a deeper gorge. Now, how are we going to draw this out? So let's look at the map again. We're now going to draw in where the watershed is. And so all the rivers then that are on the northern side or the northwestern side of the divide would now flow in a northeast or northwesterly direction. The Umzimkhulu River that was flowing in the southeasterly direction will not be as strong as it is at present because it didn't yet capture those headwaters. So that's where the Umzimkhulu River will be. And all those rivers there were flowing in a different direction before capture occurred. Now notice now when we put the map again back there, we see how the landscape has changed because of capture having taken place. So this is what the diagram would look like of the area before capture took place. Let us look at this Google image here, and you can see very clearly in the foreground, the area in the foreground is where the captures occurred. And when we think back to what the topographic map was showing, the area of capture was much more flatter than where the Mzimkhulu River was cutting a deep gorge. And so we see this area in the foreground represents the area of capture. And notice how all of those areas there on the eastern side of the Drakensberg have cut very deep valleys, whereas the areas on the northern side have got fairly shallow valleys because they're flowing in a different direction and they're not as efficient as the rivers flowing down the escarpment. When we look at the area there, that's going to be the area where capture has taken place. That's where all the water was taken away from, and now that water's changed direction because that was the position of where the watershed was before, and now it is cut back and has changed the direction of the river. And so there you see that whole area was where capture occurred. Let's look at the area of capture. Let's look at the area of capture in a block diagram. When you look at this block diagram here, you'll notice that that stream is a very little stream, but it's cutting in a different direction to the main stream that seems fairly strong in flow. But because headward erosion is occurring, look what will happen over time is that the river will be diverted in flow, and now the water, that stream that used to be a little trickle, now becomes a powerful stream. And the reason why that is so is because it's gained the headwaters of the river that it captured. And so therefore you see that the river flows much stronger and cuts a deeper channel. When we look at an example in South Africa, we see how, for example, the Gamtoos River captured the waters of the Grootrivier. Can you see there you've got the mountain ranges there, the river cut through the mountain range. Can you see at point A, very clearly there's an elbow of capture. Then when we look at the Coega River and the Bivians River, they flow into the Gamtoos River. But can you see that the Coega River was captured by a tributary of the Bivianskloof River? And there at B, you again see an elbow of capture. So clearly then we can see what the elbow of capture looks like on a topographic map, and we can also look at it on a much larger map to see very clearly how capture occurs in our the captor stream then can cut a deeper valley when river capture occurs.